Thank you, Julio. Good afternoon, everyone. Good morning to some of us. My name is Pablo Garcia. I work on the National Hydrological Service of Argentina. The name of our institute in Spanish is Instituto Nacional del Agua. And I'm here to present an interesting experience and application of an velocimetry image method, in particular LSPIB, that we are starting in a basin of Argentina. Okay. First of all, I would like to apologize for the level of my English. In this moment, I remember my parents when they told me, Pablo, you have to study English. And I say, yeah, yes, of course, but I was going to play football with my friends, or I ran away with my grandfather to the San Lorenzo stadiums to see the games of our favorite team. Well, move on. In this presentation, as I said, we want to show you the implementation and assessment of LSPIB method as support for the management of a highly polluted basin. Our study area is Matanza-Riachuelo basin. This basin is located in the Metropolitan region of Buenos Aires, in Argentina, of course. It has an area of 2,000 square kilometers. It's a plain basin with a regional slope of 0.025%. Around 6 million people live in this basin, of which 50% are not connected to the sewage network. More than 7,000 industries are installed in the basin. Industries like tanneries, food industries, lauder houses, metallurgical industry, chemical industry, and others. The basin has a very heterogeneous land use. For example, we can see that the upper basin is a rural area. The middle basin is also a rural area, but with an important industrial state. And finally, the lower basin is an urban area with a high population density, with a very contrasting social environment, as you can see in these photos. Historically, the Matanza-Riachuelo basin had significant water pollution problems. Pollution is associated with contribution of industry, legal and clandestine discharge, is associated with significant amount of population without sewage service, and is associated too with the discharge of deficient sewage treatment plants. To quantify the pollutant discharge that this basin receives, it's estimated that 55 tons of BOD are dumped daily, in the basin. I'm going to take a minute to briefly tell how we come to monitor this basin with an velocimetry image method. In 2006, attending the environmental deterioration of the basin, an inter-jurisdictional management agency was created. The name of this agency was ACUMAR, which in Spanish means Autoridad de Cuenca Matanza-Riachuelo. In 2008, the Supreme Court of Argentina intimated ACUMAR to implement a sanitation plan with the aim to improve the standard of living of the basin inhabitants and to recover the environment. Since that year, to know the status of the water bodies and assess the degree of compliance with the sanitation plans, ACUMAR periodically makes water quantity and quality surveys. In 2020, ACUMAR signed an agreement with the National Hydrological Service to carry out 3 flow surveys in several stations, as we can see in this picture, in several stations spatially distributed through the entire basin. For the first time, ACUMAR decided to use the image velocimetry techniques to make stream flow measurements. The fact that this methodology is applied by a management agency in a basin with a judicial intervention regarding the monitoring of the progress of the sanitation plans represents a milestone for our region. We can ask why use an image velocimetry methodology in Matanza-Riachuelo basin. We think that in a highly polluted basin like this one, this method have some advantage over other measurement techniques. First, LSPIB minimize or in some case avoid contact with the water. And this is really very, very important in water bodies with high levels of pollutants, like we can see in this basin. For example, in the photos below, you can see a clandestine discharge from a slaughterhouse during a stream flow measurement with ADV. It's very impressive, the red water, as you can see. Another example can be seen in these photos that show a channel in the basin with a significant percent of floating waste and clandestine domestic sewage discharge. Other reason to use LSPIB is that this low-cost technique represents an opportunity to maintain periodicity in the water quantity monitoring carried out by agencies with limited budgets. And other advantage that we see is that this technique allows to increase the number of measurements in each survey, because LSPIB measurements in several stations are faster than those with ADV or ADCP. To assessment the use of LSPIB in this basin, we made measurements in 18 monitoring stations. In those 18 stations, more than 60 videos were recorded, and those videos were recorded with different devices. For example, drone, professional photographic camera, and cell phone camera, to explore the performance of each of them. To contrast the LSPIB results, additional measurements were performed with ADV or ADCP. We made measurements in contrasting situations, clean streams, or with presence of floating solid waste, vegetation, or algae. We used two types of tracer, sawdust and shavings, and to processing the videos, we use two different software, River and Fuda. Okay, where 6 pilot videos were selected to establish the selection criteria of different variables. These established criteria were replicated in the rest of the videos. For example, the alpha coefficient was estimated using the relationship proposed in Howlett et al. The interrogation area was set at 10 to 30 centimeters with a maximum of 40 pixels. The spatial discretization was performed with 0.1 by 0.1 meter cells. We use some filters. For example, in Fuda, we set the correlation filter at 0.7 for the minimum and 0.98 for the maximum. In case of poor seeding or natural tracer, we set the minimum in 0.4. And for the velocity, we set the minimum magnitude at 0.01 meter per second. Now I will present some preliminary results and observation. As expected, it could not be measured with LSPIB in all monitoring stations, particularly those that present a large amount of algae. And this was a limitation that we found in this first survey, as you can see in the photos of this slide. In clear streams, LSPIV's performance was very, very good. The difference between the discharge obtained with LSPIV and ADV or ADCP were of the order of 10%, which shows a great performance of the velocimetry image method. We can see in this slide an example in Matanza River with really, really good agreement between the discharge from obtained from LSPIV and the discharge obtained with ADCP. We obtain good results in water bodies that present floating solid waste. In this case, the difference between the discharge were of the order of 15%. No? This is very, very good result. And we obtain regular results in streams or rivers with strong presence of vegetation. In those cases, there were problems with the season tracer. Here, the difference between discharge were of the order of 35%. Finally, as preliminary conclusion of this first survey, we can say that LSPIV performance was very promising. In clear streams or with floating solid waste, there was a good agreement between stream flow obtained with LSPIV and with ADV or ADCP. The LSPIV could not be used in section with the strong presence of algae. The presence of vegetation difficult the season tracers. And when the use of shavings were better, that the results with shavings were better than the result that we obtained with sawdust. And the performance of the video obtained with drone was similar to the performance of the videos obtained from cameras or cell phones. Well, thank you very much for listening to me, and a special thank you to the entire team of this project, some of which we can see in these photos. Thank you.
Thank you, Pablo. First of all, let me say well done. Following football and learning English and doing all this at the same time. It's done very well, I'd say. And I think this was a very, very nice closure to the workshop in the sense of showing what these kind of methods could do, what are the challenges, why it's important to keep developing them, and what is the current state of the art. So do we have any questions for Pablo?
I have one question. It's Alex. When you compare ADCP and LSPIV, do you use the bathymetry measured by the ADCP? Because yeah, if you do so, then you should have exactly the same weighted area. So only the uncertainty is based on the velocity. And the second part of my question is when comparing LSPIV with ADCP, it could be good to add also the uncertainty of ADCP. We now have some tools to compute uncertainty of ADCP, and especially for measurement with vegetation. I think that the uncertainty of ADCP could be quite important and maybe could change a little bit the conclusion of the result.
Yeah, we compare the results with from the LSPIV and ADCP. We use the bathymetry obtained from the ADCP, and we obtain the error of the ADCP measurements. We compare the results that we show in this presentation. Take account of the error of the ADCP measurement, and we use the measurements with ADCP with the low error.
Okay, but my question was, do you quantify the uncertainty of ADCP so that maybe you can have like a 95% error on the ADCP and see if the LSPIV is in this range of error?
Yeah. It's in this range.
Okay, any other question? Or if not, perhaps I'll invite Nick or Dan for some final discussion.
Well, I'll ask a question, Julio.
Okay.
Yeah, thanks. Really interesting presentation and a really nice sort of different sort of motivator for the use of these methods. I think that business of keeping people out of very dirty water is a very valid reason to try these methods. But my question actually was around, it looked as though most of the measurements were taken in times of low flow. Were they all in a low flow condition, or did you catch any in a high flow?
All the measurement were with low level condition. This is why. This is because in parallel, other team take a measurement of water quality, and this measurement must take in low levels of the streams.
Okay,